Basically, what I wanted to tell you is that when you do API logging, it gives you a very good idea of what the malware is going to do at the code level, and that is going to be input for your uh, reverse engineering part as well. So, as I mentioned, this is the source code of malware. So, in case of uh, malware binaries, you are not going to get code like this. In this, one of the things the malware does is, if you see here, directly google.com is not present in this binary. Okay, so if I search here, google.com, it is there in obfuscated form. Okay, so you can see here it is there in the commented code. Okay, but in the API logging, I saw that uh, finally, but google.com has to be formed in the memory. It has to be recreated in the memory, and then it would be used. So basically, google.com is in obfuscated form. So if I check the google.com, this is my test sample, and anyway, this is packed. So if I check here, google.com won't be there. And now when I run this with my API logger, let's see the results, what all things we get. Okay, so it has run, and let me execute this. So many of the APIs are called by the code inserted by the compiler, but apart from that, and also I have packed it. So some of the APIs are called by the packer code as well. Okay, so apart from that, if you see, if I match my code, let me start with create notebooks. Okay, so if I compare my code with the API logs, so this is my source code. Okay. So if I go to my main function and if I see here, okay, so here is a create mutex dummy malware. Okay, so this is in the API logs. In the source code, you are seeing this. Create mutex is there. You can also see here dummy malware is here. You can see here my dummy malware is also here. So you can get some idea from the API logging what APIs have been used to create this malware. So this again are input for your reverse engineering. One important thing in my logs. So this is my logs. Right hand side is my logs, and left hand side is the source code. So one important things in my logs in this tool, what I do this logging, it shows me the address from which the API has been called. So this would be an input for reverse engineering. Other tools do not provide this. Okay, so once my tool is completely working condition, it will be providing more inputs. So it shows you that a mutex has been created. If I compare more and more source code, you can see more stuff as well. For an example, I showed the persistence already, and there is something related to connecting to google.com. So google.com won't be there in my source code, but it is decrypted at runtime. But in the API logging, you can see here google.com being passed to this API Internet Connect A. Okay, so if I check here, Internet Connect A in the source code, here is how it looks like. Okay, so Internet Connect uh, doesn't directly connect to the google.com. Rather, actually, you cannot see directly google.com here. So here, basically, it is decrypted. Okay, decoded URL is there, and this decoding is done by the XOR function. XOR function you cannot see in the logs because this is not a Windows API. This is a function which I have created in my code. Okay, so when in the API logging, you are only going to see only the APIs which are uh, related to Windows API, not the functions which are created by the programmer. Okay, so whether it is a malware author or something. For that also you require the reverse engineering. You cannot see this in API logging or dynamic analysis. You have to go for reverse engineering. So we'll talk about this in the reverse engineering part, how this is done. So other things also you can see. Like you can connect with this. There is a place where I have registry run is there. So registry run entry is here. It called from reg create key. Similarly, here also you can see the same. It is called from reg create key in my logs. Okay, so you can see here, same set of APIs are being called. So this is how API logging is done. So I'll tell you about another tool. My tool is yet to be completed. So, but yeah, it has some usages like it will show you all these things and which would be input for the reverse engineering. Okay, so I'll show you another tool for reverse engineering, which has for API logging, which has much more logs or more APIs. So let me just kill this process and show you. So this tool is API it's Xlogger tool. I have given the link to the tool in uh, the PDF which I shared today. So here, let me check it. And also, you can see yesterday you guys had a question that what will happen with the packed binary, right? So in packed binary, also since API logging comes under dynamic analysis, you are going to see the code related to the unpacked uh, your unpacked binary as well. Okay, so you are if you do dynamic analysis properly, everything would be revealed. You could also see that some code was decrypted and that was also being used in the API logging. Okay, so dynamic analysis is very important. Okay, so I would be showing another tool. Its name is Xlogger. So this is again a free tool. It's present in GitHub. I have given the link. So this is another API logger. So let me go to this. Okay, so I'll be testing my test sample here. So I'll show you the difference in the output. So any tool, whatever I use, I prefer to use them. I prefer them to run as an administrator so that the tool works very properly with its all privileges. So here Xlogger is the tool name. Xlogger. I can provide minus C. Minus C is the which is the binary I need to provide. So in this case, test binary is the tool, binary name. And after that, I need to provide the log file name minus L. And after that, uh, test sample logs.txt. So here it is working on it. And after that, it will create some logs which we are going to see. Okay, so just a minute. Test sample did not run. Okay, anyway, we can refer that again. So basically here also logging is done, but here, if you see here, the API logging has been slightly looking bit different. It doesn't look like the exact Microsoft parameter. So sometimes if somebody is new, it would be harder. Okay, so new to analysis, it would be harder. And you can see here, similar same APIs names are not going to change. They are going to remain the same. But the way it is logging is slightly different. That's the only thing. So you can see all the APIs are there. Okay. So this sample did not run completely. I think I missed to kill some of something. I have to reset the revert back the VM. I'm just in shortage of time. I'm not doing that. So we'll next move to another sample that is a real malware sample. Till now we looked into a sample which was just a dummy sample. We're looking into a real malware sample. The sample name is Remco's rat. We'll look into how it looks like when we do analysis. It's basically a keylogger. Okay. So let me switch samples. So this is my Remcos malware. So let me run procmon on this and see what happens. So let me make this name a bit smaller. So, when you download a malware in Malware Bazaar, you'll always see name like this. But if you download somewhat from Virus Total, your name would be somewhat like this without any extension. Okay, so that is what you in the initial step, that you need to determine what the file extension it is. Okay, so often as a malware analyst, you will get file names like this. Okay, so let me rename as file. So I've named this. You can see here how the icon looks like. Now let me execute this process. Let me run. Let me run Procmon. Just give a moment. I'll just revert the VM. So Remco's, just to give an information, Remco's RAT is a stealer as well as a keylogger component. It has all the components. Okay, so it is generally we'll call it as Remco's RAT. It is used by some APT groups as well. So let me do that. Something wrong with this. Okay, so yeah, so Procmon problem. So I'm restarting it. Okay, so you can see Procmon is creating a lot of logs. Now I need to again do the filtering. So this is my uh, malware RAM cost. Now let me start Procmon and then execute this. Started Procmon and now let me execute this. Okay. So I can check in Process Hacker whether it is executing or not. Your MCOS rat is executing, and after that I can stop it. Uh, so let me show you some key features of this one. Okay, so Ramcos, what it does is you can see one. Okay, so Ramcos, what it does is it creates a folder in your app data location, and it creates something file known as logs.dat. So by default, it is hidden. So what I've done is I've made it visible by changing the folder options. File option is there. Okay. So you can see here it created a file whose name is logs.dat. Okay, so you can do the same thing, like you can go to the process tree and after that do the filtering. You can see the logs.dat. So basically, this is a file. So what this file does. So let us look into what's happening in this file. So let me open Notepad and drag drop this one to it. Okay, so if you observe here, see what's happening here. So whatever activity I'm doing in my system, okay, so everything is being logged here. Okay, for an example, I did Control C, Control C, I pressed Control C, everything is logged here. Okay, so if I do uh, something it says that it is copying to what. Other than that, you can see the process names also here. Okay. So let me type in, let me do something like this. So it has slowed down the system a bit because I have assigned a less RAM. I am Abhijit. Let me put as NIT. Okay. So now let me check what is the log inside this. So let me check here. So what inside? So it might take some time. Okay, you can see here NIT is there and M Abhijit. Okay, backspace also I did, it was logged. Okay, so you can see here all these things are logged. Okay, so even my backspace is represented with a special character BKSP. Okay, enter, whenever I pressed enter, it is also special uh, characters are a special word is used to represent enter key. Similarly, other things like whatever anything I am running on my system, whichever window I am switching to. For an example, I switched to Notepad. It also showed me. So I entered Notepad. I went to start. I went into Notepad. After that, searched, put Notepad and enter. Everything is logged here. That means this is a keylogger. Okay, so this is how keylogger works. So this is a real keylogger. Okay, so Remcos works like that. So let us look into how it has been coded. So how to find out how it has been coded. So uh, one is reverse engineering. So before reverse engineering, so we have to do a thorough dynamic analysis. So Procmon is one of the dynamic analysis we did. So, but here we are not going to get an idea what is happening at code level. Some other stuff also you can see in Remcos. Remcos, if you go to handles, you can check also mutex here. Let's see if it creates some mutex or not in this case. So some malware they have. Okay, so here it is created mutex, and mutex is very specific. It says the name of the mutex is remcos underscore some plot in here. Okay, so if I run it twice, the remcos won't run most likely because this mutex is present as long as this process is running. So I have to kill this process in order to run it again. So I would be running this Remcos rat with the help of API logging tool, and let's see what happens. So I would be using here Xlogger tool because my API logger tool doesn't log certain APIs which are used by keylogger as of now. Okay, so now let me take this Remcos rat. Let me name it a bit small. So let me take it to Xlogger path and see, check there. Okay, so here also, if you see in this case, also the tool has two versions. One is 32-bit and 64-bit. So again, your basic analysis comes into picture here. So if you found that your tool is 32-bit, then use the 32-bit version of the tool. While if it is 64-bit from the static analysis, use the 64-bit version of the tool. So let us run this tool under Xlogger. I go to this path. So this is a command line path. Xlogger. So this tool you can download from the internet. It's free of cost. If you just run it, it will suggest you what kind of command what kind of parameters it requires. So here -c stands for the path. So let me put here remcos. Okay, -l is the log file. Here I put like remcos api log.txt. So it will run and will it run? Might take some time. Hopefully it runs properly. So sometimes if something doesn't run, you have to reset your machine and do something because malware might have some remains on the system. We might not allow the malware to run in. But since we are doing in a short time, I'm not doing a practice of reverting the machine. But ideally, you should always revert a machine. Okay. So when after executing a malware, you can see a lot of logs are there. Let me open this. It might hang my system, my notepad because so many logs are there. It's 58 MB or so. Okay, so here you can see a lot of logs are there. So in this, what is the set Windows book? Taking time. It's taking a bit time. Okay, so I'll tell you some of the API names which are important here. Okay, so basically, uh, some of the APIs which are related to hooking is set Windows hook EX. Okay, Mukul, I'll answer that. Okay. So basically, you can, if you want to know many of the APIs used by malware, these are some of the APIs which are used by malware. So the site name is Mal API. You can note it, Mail API, Mal ML API .io. So it's not necessary all these APIs have been created for for just for malicious purpose. All APIs have certain purpose. That's why Microsoft have developed them. But unfortunately, malwares misuse them. So here is a long list of APIs. You can see their documentation in MSDN and other places. In this place also there is documentation and there is link to the Microsoft website as well. Okay, so you can see all the APIs. So this is a huge repository, malapi.io, where you can see all the APIs being used by the malware. Okay, so this is something useful for you. Okay, coming to the question of detecting by detecting with the help of IDS and IPS. Yes, malwares can be detected by IDS IPS provided you get some network patterns in your Wireshark logs. You can see what kind of pattern is sent by the malware or what it is using or what kind of communication it is using. Based on that, IDS IPS it can be detected. Okay. Other thing is by behavior, like one of Remco's rat, if you particularly see, it always creates this particular file logs.dat onto the system. Okay, so you can say Ramcos rat creates a certain file, and if you want to want a very specific signature for Ramcos.rat, then uh, logs.dat is a file created by most of the ransomware variant in app data folder in Ramcos and dat. Okay, so this is one way of detecting. Another way is you can check the memory for the strings. We'll talk about detection in memory analysis. Okay, and after that, also the API logging is also a mechanism. Okay, some of the APIs somehow it is taking a bit of time for logging because so many logs are there. Okay, so something is it's hanging the system. Okay, so it's getting so many calls and all the things are there. Some APIs are getting missing. Okay, so it's still stuck up here. Okay. Uh, so you can see here that also it created. If you see the logs, more activity are seen. Okay. So let us see else something else APIs are there or not. Okay, still something is going on. Okay, so in the backend, it somehow misses the logs, but you can see some of the things happening in the code level. That is, it is creating a process. What process it is creating? So basically, most likely, it has dropped some bat file into temp, and it is using that bat file. Okay, so it would be using something maybe self deleting or something. If I scroll backwards, there are more APIs. Most likely, it has to delete itself. So that is why this malware, the API logger is not able to track. Okay, so this API logger has a bit of problem. Okay, so yeah, so it is still something is happening. It's taking a longer time. Okay, so for API references, you can always check this site and see the API logs. You can go to MSDN. You can click here and go to the MSDN. Okay. So I this is about Remcos rat. So there are other malwares also in remote access trojans. You are going to see logging and other activities. So I can show you some of the logs of some of the APIs. Let me fill this. I have some logs of some of the APIs, some of the malwares. Okay, so I'll give you an idea from the source code itself. Okay. So basically, this kind of see this thing I won't be able to share. This is a bit very specific to my commercial training. Okay, so I just wanted to give an idea like what different kind of APIs can be useful. Okay, so if you see something like this resource related APIs, so these basically malwares, they have some binaries embedded in themselves, and after that they would drop them, and after that execute or do something else. Sometimes they might hide some information in some resource also. So basically your p executable has a resource section. Okay, so in some cases, not all, so malwares can hide themselves there. Okay, so proper can hide the malware there. So if you see something like this, find resource, load resource, and after that create file would be there, then it is most likely a dropper. Okay, uh, and after that, these are some APIs related to registry. Okay, so I'll give a quick overview. Like reg create key, reg set values, we already saw. Okay, so these are usually present there. Service related APIs, like malwares might sometimes create service, uh, create themselves as a service. Okay, so that is useful when malware are doing lateral movement and do some other stuff as well. So you will see some set of APIs like OpenSC Manager is there. Okay, so OpenSC Manager stands for Open your Service Manager. So this stands for Service Manager. Okay. And after that, create service is there. So all these APIs you would be seeing in API logs. Uh, Other things you would be seeing, like for an example, many malware try to steal the system information. Okay. This is an example here. So you'll see if API is being called like get computer name and get username and get system directory, most likely the malware is trying to access get the computer name, which it might be sending to the attacker. Okay, so this tells that malware tries to figure out the system computer name, and this is quite common. Okay, so many malwares try to do it. Process iteration, if the malware is looking for a certain process, so this is the common code. So this is present in clean as well as uh, malicious binaries as well. So if a malware tries to find a particular process for some reason, maybe it will try to kill some process, it will try to inject some code into a process, you are going to see code like create tool 32 snapshot, and after that process 32 first and process 32 next. After that there would be a string comparison. So basically create tool 32 snapshot. Okay, so this is the most one of the most commonly used APIs by the malwares. So create tools 32 snapshot on a Windows machine. It gives you a kind of list of all the APIs. List of all the processes on the system, and after that, process 32 first and process 32 next will help you to iterate through the list of the processes. So next API is load library. So load library loads uh, a particular DLL into the memory, and with the help of get proc address, it can get address of certain. It gets the address of a certain API from the DLL which it can use. Okay, so these are some commonly used APIs. So so another commonly used APIs is related to virtual memory access. Okay, so malwares, this might be used for code injection or decryption, any other purpose. So the commonly used APIs you will see like virtual alloc. Virtual alloc is very similar to malloc. Okay, it allocates a certain memory in the virtual memory. Okay, it will allocate address in the sorry, it will allocate some memory within the virtual memory and return its address. And write process memory can be used to write to that particular memory. Okay, so it can be used in code injection as well as other places as well. Okay, so create process, it creates a brand new process. Okay, so it will create a process. Okay, so this create process is the API for creating new processes. Other APIs can be shell execute API is there, and WinExec is also there. Special folder path. So why it is used? So there are special folders on our system. Special folders are like temporary folders, your app data. So these are all special folders. Okay, so malwares try to drop files into temporary folder and app data. So that can be used. These APIs can be used for that. Okay, so these are the APIs here, like sh get known folder path. Okay, like it, folder ID roaming app data, it will get you the path of app data. Okay, and malware can drop there. Get temp path, it gives you the folder of the temp folder location of the temporary folder. Okay. There are like create file, write file. This can commonly used by the ransomware. So all those APIs you are learning here are input for the reverse engineering. Uh, I would suggest you to go through this mal APIs, get an idea at least, so that it would be helpful in reverse engineering part. So another thing I wanted to show you, like how to find out a code is injected. Okay, so I'm not using a malware here. I'll show you with a dummy sample so that you get a idea of how it works. Just give me a moment. So this is a dummy sample which I created using this for code injection. Here I would be using mal API logger because here I have already put the code, the APIs which are related to code injection here. So I can show with xlogger as well. So what this, so here the dummy malware is shellcode injector, and target.exe is a program. If I run this program, this shellcode injector, it will try to search for this target.exe, and when it finds this target.exe, it is going to inject there. So let us see how it works. So basically, this is my target.exe. It is running. Its PID in decimal is 79172, and in hex it is 23D4. Okay, so let me run my shellcode injector and see what the logs. Its logger is there. Sorry, Malware API logger is there. Let me run this sample. So I'm running this injector. Okay, so my shellcode injector has run. So we would be seeing what are the APIs responsible for code injection. So if you see here, so these are the logs. So as I told, the malware would be trying to find out, will try to find out the process name target.exe and after that inject into it. So how do I see from the logs? So first, in order to find the processes running on the system, it uses the API create tool32 snapshot. After this API, it gets you the list of all the processes in the system. Okay, and after that, using process 32 first, it locate the first uh, process. So these are the structures related. This is a list, and each node in the list represents a particular process, and it would be having the attributes of the process, like process name, PID, other thing. So this is basically a structure. Okay, so each one The list is a structure representing a process. So process 32 first, it accesses the first member in the list, while process 32 next can be used to access rest of the uh, structures in the list. So you will see after process 32 first, it checks for the next process, then process 32 next. Okay, so it will go on searching till the point where it finds target.exe. So you can see here, go down, down, down. There are many processes are there, and let me search for target here. So here it process 32 next finds the target.exe. Okay, so after that there would be certain comparison, and once the target.exe is found, the search stops. So you are not going to see any further process 32 next after this. So next, once the process is found, its PID is its PID is 9172 as we see. So it's 9172 is the PID of the target process. So if you see here, it opens the process. Okay, so firstly, in order to inject, it will open the process, and after that, allocate some memory. So it allocates a certain memory whose size is some 500 bytes, and what address it allocates? It allocates the address. It allocates 5340. So this is the address in which it allocates the memory. Okay. And after that, it writes some code to the memory using write process memory. Okay. And after that, it starts the thread in the process. Okay, so whenever you want to execute a code, you need to start a thread. Okay. So basically all these are steps for uh, you know for injecting a code and executing it. So you can check these codes also in process hacker. So as I saw here, what does my log show? Log shows that my code has been, a memory has been allocated to 5340, and after that code is injected to it. So basically target.exe, yeah, this code might be sometimes removed if the work is over. Okay, let's see whether it is there or memory. And after that, you can see here 5340s are there. Okay, so you can see here the address matches here. Okay, and if I open here, so there is a certain code here. So this, if you translate into disassembly, certain meaning will be coming out. So this is a shell code. Okay, a small piece of code that does nothing but starts calculator. So you can see here a calculator has been started here. Okay, so this is the result of injection of this code. So the code injection forcibly made target.exe open calculator.exe. Okay. So, but the target.exe did not have the actual functionality of starting calculator. So the malware, what did it made its malicious code, this shell code, inject into target.exe, and through target.exe, it executed the malicious code. Okay, so why this kind of technique is used? This kind of technique can be used to bypass, antiviruses, EDRs, or anything, or your local firewalls. Okay, so EDRs can catch it by the behavior, because EDRs, if they are able to see this logs, API logs, they can catch it if they are logging it. Another thing you will see is like tools like Volatility catch this kind of things. If you see here, when I injected the code, the attribute of this page is read write text. So Volatility will, which is a memory forensics tool, when it checks the memory, all this virtual memory, it will say that this is a RWX, means some code is there. Okay, some item, some executable code is there. Okay, so let's check it. So it will, volatility kind of tools would be using this. So I would be taking up the volatility memory forensics class also. There you would be seeing something related to this. Okay, so if you understand this, your using volatility would be much easier. So this was about code injection. Uh, okay, so there are many types of code injection used by the malware. So one I would suggest is, if you want to know more and more APIs, I would suggest you that uh, look into the look into source code of various things, like what is happening in your Windows system. If you want to do a code injection, try to search for some code. There are many codes out there. Okay, so you'll get an idea of what APIs are uh, being used by malwares. Okay, so that is the only way to learn. Uh, you have to refer to open source tools, open source codes. Okay, so then only your reverse engineering or malware analysis would be much easier. Okay, so it will take a bit of time. Okay, but you are going to know a lot of stuff after that. Okay, so more stuff I wanted to show. Okay, so how does a ransomware API log looks like? Okay, so this is a ransomware API log. Okay, so let's see how it looks like. So this is a very big log. So it takes in Notepad it will hang. So I'm opening with this tool. Okay, so there are certain APIs. Excuse me for a minute. So this is one of the ransomware. Okay, so uh, this has certain things in its resource section. So you will directly see some APIs related to find resource, size resource, and load resource. Basically, the ransomware hides certain keys in the resource section, so which would be extracting, and after that using it would be hiding some more stuff as well. So after that, you are going to see some APIs related to cryptography. Okay, so what are the cryptography APIs? Okay, encrypt is one of the APIs which is used for encrypting a certain buffer. Okay, so this is one of the APIs used for encryption uh, uh, by ransomware. It can be used for encrypting other things as well, like your when the malware is trying to communicate with the internet, right? Trying to communicate with the CNC, you might encrypt some data as well. Okay, so for key generation, also certain APIs are there. Okay. Uh, like Gen key. Okay, so this is API for key generation. Okay, so we'll talk about ransomware tomorrow. Okay, so I'll give you a brief idea of how ransomware works. Okay, and some other APIs are also they are related to encryption. Other than that, the one of the key components is like how do you see a ransomware is accessing a file and after that encrypting it. So one of the APIs is set file pointer. So basically, if you see here, see what it does. Okay, show another one. Okay, so what is the ransomware doing in this case? So if you see here, it starts ransomware tries to find one file. Okay, so before that, ransomware it searches your entire file system. In the file system, if it finds a file, it will check for whether it wants to encrypt the file or not. What are the parameters? So one of the parameters is ransomware checks whether it is a some kind of file extension is there or not. So if you check here, this API is used for comparing the file extension of a certain file. So when ransomware encountered this file copying.txt, it compared with the extension whether .txt I would be encrypting or not. So in this case, .txt matches. So hence it goes further to encrypt this certain file. So here, if you see, create file is used to open this file copying.txt, and after that it gets the file size. Okay, so ransomware also checks for if the file is very small, it is not going to encrypt it because most likely it is not going to have any important data. So in this case, the ransomware also checks the size of the file using this API get file size. After that, there would be some comparison which we cannot figure out from the API logs. Reversing is required. Okay, after opening the file, it sets file pointer. Sets file pointer means it has to go to a certain location in the file. So malware, what it does is, this ransomware, it does is, it say suppose this is the entire file. So you can say the ransomware picks up uh, a certain size buffer from the file. After that, takes it, encrypts it, and then writes it back to the file. Okay, so similarly, it will go on. It won't encrypt the entire file at a time. So it would be taking chunks, right, encrypting it, writing it back. Okay, so this is what is happening here. So set file pointer helps you to uh, place the pointer in a certain location. After that, it reads the file. Okay, read file is used to read the buffer into the memory, and after this, encryption is going to happen. So it read a certain location. After that, encrypt is there. After that, again, it will do a set file pointer and write file. Okay, so you can see the sequence here. Okay, so if you see a ransomware activity, you will see always this sequence would be set here. Read file, okay, your set file pointer is there, read file, crypt encrypt would be there in case the ransomware is using Windows cryptography's APIs like crypt encrypt. In case the malware ransomware is using some open source APIs or some APIs which the ransomware author has created, it cannot be logged in this because that is not a Windows API. So this is how ransomware logs look like. Apart from that, there are some extra logs. Okay. So tomorrow I would be showing you how to do a static code analysis of ransomware using Hydra. One more thing I wanted to tell you about the ransomware is uh, something related to encryption. So people always ask me, can ransomware be decoded? Can ransomware files be decoded or not? Okay, so let me talk about this here. So how the ransomware cryptography works. Okay. Okay, so let me give you a brief idea about how symmetric key, asymmetric key, and all those fundamentals. Okay. So basically, if we talk about encryption, there can be two types. One is symmetric key and one is asymmetric. What is the difference between two? Symmetric key, encryption key is the same, and decryption key would also be the same. In case of asymmetric, ideally, I would say encryption key would be different from the decryption key. So further, these are the classification. I don't want to talk about them. So in symmetric key, what happens? There is a sender and there is a receiver, in which the uh, encryption key encrypts the plain text, sends the cipher text. Okay, and the receiver can decrypt the cipher text with the help of the same key. Okay, so but in case of public key, what happens? So the sender has generates a public and private key pair, and after that, uh, it public key is sent to the receiver. Now, plain text is encrypted by the public key, which is uh, encrypted now, and it is sent to the sender, and the sender can now decrypt the message because it has the private key. As you can see, the public key encrypts the message while the private key decrypts it. Okay, so now ransomware, what they do is, they ransomware nowadays they use a combination of uh, symmetric key and uh, public key cryptography. Okay, so how does it work? So here is an attacker. Left side top is the attacker, while right side bottom is the victim. So the attacker creates a RSA private key and RSA public key, and after that he embeds the public key into the ransomware, and it is sent to the victim machine. On the victim machine, what happens? The ransomware generates a symmetric key, and this symmetric key can be used to encrypt the files on the victim machine. So this symmetric key is very specific to the victim. Okay, so no other victim would be having the same key. So you can say on different victim, the same ransomware would be creating a new key, and for each victim, the symmetric key would be different. Now, what the ransomware does is, ransomware has a embedded public key in itself. So what it does is, it encrypts this symmetric key, which is used to encrypt the files on the victim machine, with the RSA public key. Okay, so now the problem is, you don't have the key which is used to encrypt the files on the victim machine. So that is encrypted uh, that key is encrypted with the help of RSA public key, and it can only be decrypted uh, only when the symmetric, only when the private key is retrieved from the attacker. Okay, then only this can be decrypted, and then only this key would be retrieved to decrypt these files. Okay, so this is the challenge here. So in some cases, yeah, people have been somehow able to get this private key and they are able to decrypt it, but it is today it is very hard. So if this is broken, if this encryption technology is broken, you can say everything in the world breaks. Okay, so ransomware very well utilize this kind of technologies. Okay. So this cannot be broken. If somebody somehow compromises the infrastructure of the attacker, they might be able to access this private key. Okay, so then only uh, you might be able to get back the key and decrypt. So practically today, uh, since because of this reason, many of the ransomware encryptions are very hard to deal with. Okay. So earlier ransomware, they used to only encrypt the files with symmetric key, and antiviruses used to, antivirus engineer, they used to debug the ransomware and find out what that symmetric key is and use to it to decrypt. But now it is not like that. Okay. So this is all about it. So these slides I won't be sharing because this is somewhat very strict to my trainings. So you can find some of those videos on the YouTube link which I shared. Some of the videos are there, some parts are there, so you can share. And the tools which I shared is in the GitHub repo. You can refer those. Um, yeah. So tomorrow we will be talking about the reverse engineering part. So all those knowledge, whatever you gained here, we will be utilizing there tomorrow. Now let's go for the question answer. Vikas, questions?
Yes, sir.
Um,
So, participants, if you have any question, you may put it in the chat box.
are you executing the malware inside Windows or not? Windows not in isolated environment. Yes, I'm executing the malware in the Windows isolated environment only in the virtual machine. Okay. So it is there in the virtual machine, but I did not revert the machine because it is going to take a bit of time. The IDS IPS answer I gave you that you have to find what kind of uh, network patterns this repository is generating, and you have to figure out what can be a generic rule to detect this repository. Pooja, how we can detect the ransomware early? So this is currently a challenge. Okay, so this is a problem because see, theoretically it can be done. The problem is like yesterday, I think initially there was a talk on ransomware detection. Okay, so there are certain challenges. For an example, while implementing a product, not as a project, but while implementing as a product and doing commercially, so some challenges are there. Like for an example, there was a talk related to dropping uh, this trap files. Okay, so customers don't allow that. That is one problem. Another thing is ransomware are too fast. Okay, so if I try to log the APIs of ransomware, so in system by default always some file and things are going on. So logging of APIs might not be helping to detect often. That can also cause a problem. So still ransomware detection is still a challenge in the industry. It they are means early ransomware detection. Okay, so later stage later on it can be detected, but like for an example, if the ransomware calls the victim, it could be detected, but that by that time everything was too late. So how early we detect? So ransomware early detection is there, but it's not perfect yet. Some challenges are still there. Okay. I was also into ransomware development of anti-ransomware engine. So there are some challenges because some performance issues are the problem. I'll start encrypting. Can't we automatically shut down the system? Okay, see here the start encrypting means the main challenge is here. How do you find the encrypting of the file? So there is a challenge like monitoring of the file encryption is, uh, when you access a file, it on your system millions of files are accessed. If you see Proc1, you can see how many files are getting accessed. So monitoring file accesses this thing. That's what causes the performances antivirus areas. But they have come up with solution like, for an example, certain number of files are encrypted. After that, detected. Okay, but not 100% from the very beginning. You told that you would be providing summary of the tools. Yes, I've already shared the tools in the PDF. Vikas sir, have you shared them the PDF?
Yes, yes, sir. I have already shared. Uh, I would
And
request, sir, whatever static PPT is not shared. Actually, it was for malware analysis part.
mhm.
So, participants were asking for those contents that were delivered in the last session tomorrow and maybe today.
Okay, okay. See, some parts are
Yes,
the
I do.
they cannot.
That I have already told them. But
Yes,
definitely, if even if a outline would be there with
yeah,
very abstract topics, it would be
yeah.
helpful for them to basically explore the topic further in future.
Okay, okay, okay. Yeah, animations I won't be able to share.
No,
That's
no,
true.
no. We don't need the animation, sir. We just need
Yes,
the
yes.
content so that they can we may explore those topics again.
Yes. And another thing, see, all the tools whichever are written, you can. I believe that I've given the list of the tools. Okay. So I think I've given all these slides. Okay. So in the last, I've given the list of the tools. Okay. So these are the tools. So these tools are very straightforward. Okay. So you just, that's why I've not kept a screenshot of these as well. Because if you run the tool, it will tell you just what to do. This is just like a Procmon tool. If you run it, you have to hover over this because documenting this is very, very time taking. Okay. It has many, many buttons. Okay. So that's why I show in the live class. Okay. All the tools like bin text, all are drag drop tools, process dump, it's a documented, Xlogger is a documented tool. I did some mistake here. This is for Xlogger. Sorry, this is Xlogger and this is process dump. Okay, so all the tools are well documented. Let me show you here. So see, many of the tools you need to read the documentation. Okay, so let me show you here. Okay, so it shows you Xlogger what it does.
So your screen is not visual, sir.
Okay, so these are the list what I've given. Okay, so trade I showed you yesterday. Rockmon I showed a demo. Okay, so see many tools have many features. Okay, it's very hard to document. Okay, so only thing is like Prockmon is a very big tool. Okay, so one I've given overview like looked into. If you see here, I've given an overview. What you see in some of the tools. Here I've told you like price created, registry created. Okay, so all the tools means. One thing implementing them all the feature is very hard. So I've given a just idea. You have to explore it. Like treat is a very easy tool. Run it, you'll see what with a file you'll going to immediately see what it does. Okay. So other tools which I told like Xlogger tool which I was just showing. So if you go to their website itself, it is going to show here. I've given you this link. You can see here, right? Xlogger tool is there, minus C is there, minus L log file is there. Okay. So you can see here, right? What it is doing. And another thing is process dump Malware API logger. This is my code. Okay. So you can see here some videos also I put. Okay. Malware API logger tool is there. So there are some video tutorials also. Okay. This is the basic. Uh, GitHub Xlogger. You see here. Okay, Xlogger I showed, I guess. Another is process dump. Process dump, I have given the this log only. You can go to the process dump. There will show you how to do it. Okay, PID, this is the thing. Okay, so I'll give you some hints anyway. I'll try to give that because that remains documented. But yeah, the tools have more features. Okay, so what I would suggest is whenever you want to learn, like hover over, see, these are UI based tools, right? So if you just hover over something, you will get some answers. But it has many things. So many tabs are there. Okay, so like here general tab is there. So I would suggest like try to explore the things like what are threads, what are modules. Okay, go on clicking. Okay, because some I can give, but not all. It takes some time. Uh, is this okay, Vikas sir?
Yes, it is completely fine, sir.
Yeah, yeah. You need to explore because it's tools have many features. Like tomorrow I'll be showing Githra. Okay, so Githra has many features. You need to every tool has many things. Okay, so I'll show you some points I can give you, but still you need to explore. And what will happen is, say, suppose the tools change because I have seen Procmon changing 3 or 4 times in past years. Even this process hacker changed to some other tool system informer. That time you need to explore the UI. Okay, so fundamentals are the important thing. Don't rely on tools. Okay, so always don't rely on tools. The fundamentals. Okay. So any tool, whatever I told, I've given you the list. I would suggest you as a homework for today, open the tool at least in your virtual machine and see, explore something. Okay, because at least UI tool you can explore, run the commands and see. Okay, see what you are getting. So the list I've given already, whatever tools have been used. Any other questions?
Sir, there are few more questions, sir. It is in the chat
If
box.
the system is infected, what are the steps we need to follow so sufficient information available for malware analysis? Okay, so this is kind of more like an incident response. So first is what the signals your system is generating. Okay, so either you are in a corporate network, depends upon that. What is there with you? What kind of, why do you say that the system is infected? For an example, in a corporate network, say suppose you have a SIM. Uh, so in SIM, you can see a lot of things. Again, if you suspect, use Wireshark. In Wireshark, see that in Wireshark, are you seeing any network communication which you are not supposed to do? Okay, like for an example, if you get an IP or a URL which is not connected to Microsoft, it is trying to connect to something. Okay, it is connected to some country like Nigeria or something. Okay, check out all those things. See what is anomaly basically, I would say. Okay, after that, from the network connection, try to find out which process is trying to do the network communication. So here Wireshark is not going to help you. Here you can use tools like Microsoft Windows, Microsoft Network Monitor, and another tool known as Fiddler. Okay. Is there any type of, okay? So this about the uh, this is one of the things, and after that, check out the persistence mechanism. Okay, so that is very important, whether something is persisting on a system or not. So you have to be aware of what all softwares are installed on your machine. Okay, so otherwise, many clean software also, as I told, they are used for persistence. Same things. Another thing is there any ransomware type that infects MBR of a vulnerable system? Not vulnerable system. There are ransomware that infect MBRs. Okay, uh, it is there, but after these days, um, I think not easy to encrypt the Windows 10 because of some protection. Okay, so that is the thing. It's not about vulnerable. It's just like the system has been designed. It allows to access the MBR. That's it. Not only vulnerable. Vulnerability is for getting inside the system. What is this sin called track? Okay, which is better and more? Okay, so I think this is syscall. See, syscall tracking. The problem with syscall is tracking is performance. Okay, so yes, it gives you more data, but the problem is your system would be slow. Okay, and hard syscall tracking is harder to implement. So uh, API tracking is easier relative to syscall tracking. Okay, another problem with syscall tracking is syscall numbers would change across operating systems. That is another problem. So syscall is better, but it has challenges. Okay, implementation challenges are there, performance challenges are there. One tool I read Sysmon, which is better than Procmon. So Sysmon is a slightly different tool. Sysmon is what it does is it does event logging on the system if you configure it. So that can be used for forensics. Okay. Syscall is a concept. It's not. See, you can see in the debugger how the syscall happens. Okay, so syscall happens. API would be internally calling the syscall. So malwares instead of calling the syscall, they would be calling the APIs. Sorry, malwares instead of directly calling the API, they can call the syscall directly. So syscall is called by with the help of a number actually. Okay. So it's not a tool. Every API call this is called internal. Okay, so there is a SSDT table where syscall numbers, all these numbers are there. What if you use this process? It may be, if we use this process is may be right. I did not understand this one. Lakshmikant, can you repeat this question properly? If we use this process, it may be a right thought. What does it mean? Lakshmikant, can you tell me the meaning of this one? Can you repeat it again? Yes. Are you repeating something?
Anyway, sir, we are already at
Right.
the end of the session. Actually, the next session will be starting from 5:10.
Yeah.
So I hope the question you just keep it with yourself. In the next session, you may just put the that question so that sir will answer the question. Okay. So thank you so much, sir. Okay, the question is, I think, this process is named safety concern. So it is there, but you may have a look at that. This process is increasingly important safety concern.
Which process are you referring to? Still, I can't understand.
Maybe
Maybe Vedant, you can take over the question and ask me later. Since
we will discuss in the next class, next session. Thank you so much, sir. So we will meet tomorrow.
yes.
Okay. So participants, we are having the next session on Android malware that will be taken by Dr. Meenakshi Tripathi. So just wait a few minutes and she will be joining soon.